Imagine you are an engineer and you work for a consulting company and you are in charge of calculating the load that is going to be used in order to design a bridge. So let's say you have your bridge here. You have your nice bridge here, and you need to make an estimate of what is the load that we should use in order to design the bridge so it doesn't fall under the load of all those tracks. So you make all your calculations and you determine after the whole night working that the load that is given by your computer, the final result is 319,924.23 pounds. So you have to give this number to the other team that is in charge of the design of the bridge. If you give this number like this, everybody's going to laugh. Why? Well, because say this 4.33 pounds doesn't make any difference when you need to design a bridge that is supposed to hold more than 300,000 pounds. 4.3, 4.2, 4.4 pounds doesn't make any difference. Those numbers here don't have any meaning. So we as engineers deal with the term significant digits in order to provide numbers that make sense and get rid of a bunch of digits that really don't make any difference in our calculations. So if you tell the other team that you need, they need to calculate the bridge for 320,000 pounds, that will be more than enough. In a bridge that is supposed to hold 320,000 pounds, 1 pound more, 1 pound less, 1 pound more, 1 pound less is not going to make any difference. So we need to learn how to provide our final results with the enough significant digits to make sense and not fill the paper with a bunch of digits that really don't make any sense and provide just a complication that is not necessary. So that's what I'm going to talk about here. Let me give you another example. Let's say I like origami, and I'm going to make 3 little doves, origami paper doves. So I have a piece of paper here. So I have a piece of paper here, and I need to cut this paper in 3 papers of equal size. So I have my paper, and I see that it measures 11 inches. So I need to cut it in 3. So I go to my calculations. 11 inches divided by 3. So 3.666666667 inches. And actually, I hate to work in inches, so I do more calculations. So I multiply by 2.54. So it's 9.3133333333 centimeters. So how do I measure 9.311333 centimeters? I go to my scale, and here, actually, I really don't bother about all those 3. 9.3 is enough. So 9.31 is even more than enough. 3 significant digits for this case of an origami paper of 3 significant digits is more than enough. So instead of working with 9.311333, because the third 3 that I see there is not even, there is no way to measure it here with my ruler. So 9.31 will be here, 9.31 here. It will be 9.31. I don't see the difference between 9.31 and 9.32. So I proceed to do. So you see how all those digits that you get into the calculator are really not necessary. You have to learn to round those numbers off to a very reasonable number of digits in order to make the work practical. In this case, this 9.313333 is going to be just 9.3 for this paper dove. It's more than enough. In engineering, we will work with 3, 3, or 4. All right, so let's take a look at the rules in order to verify the significant digits. First rule, all non-zero digits are significant. So 1, 2, 3, 4, 5, 6, 7, 8, and 9 are significant digits no matter what. So in this number that I have here, 73.495, we have 5 non-zero digits. So this one has 5 significant figures. Rule number 2, zeros between non-zero digits, we can call those also captive zeros, are significant digits. So in this example, 0.003008, these two zeros are significant also. So we have these two significant zeros, so significant digits, and the 3 and the 8. So here we have 4 significant digits, 4 significant figures in this example. Rule number 3, trailing zeros after the decimal point are significant. So in these two examples, these two zeros that are after the decimal point, those two are significant. So here we have 7, 3, two significant digits, and el zero, and these two zeros. So we have 4 significant figures in this number, significant figures. And the other example, these 3, 4, and 6 are significant because there are non-zero digits. And then these two zeros are significant too because they are after the decimal point. So here we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 significant figures. 5 significant figures. Rule number 4. Trailing zeros in numbers larger than 1 without the decimal point are not significant. So in these two examples, this 230 here doesn't have the decimal point, so this zero is not significant. So here we only have 2 significant digits, the 2 and the 3. So this is 2 SigFigs. On the other hand, this other example, we have the decimal point here. So this 0 becomes significant because of the presence of the decimal point. So here in this example, we have 3 SigFigs. All right. Rule number 5. Leading zeros or zeros to the left of the number are never significant. So in this example, these 3 zeros are not significant. Therefore, here the only significant digits are the 7 and the 5. So this example has only 2 SigFigs. Okay? So those are the rules that we are going to take to use in our course here. So not complicated. Take a look slowly and make sure you recognize what is a significant digit and what is not. So in our engineering practice, we are not so much interested in counting the number of significant digits that you find on a number. What we have to do is we have to be very good at looking at a number that you get in your computer or in your calculator and rounding it off and give it to the next engineer with just 3 or 4 significant digits. So we need to be able to cut the numbers down to the number of significant digits that we want. So let's do some examples about that. Let's do this example like this. Let's count how many significant digits we have in these numbers that we have here on the board, and then let's rewrite the number with just 3 significant digits. The first number, how many significant digits we have here? Well, the 3 zeros that we have here, these 3 zeros are captive zeros, so they are counted as significant digits. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 significant digits. Let's put here, these are significant figures. So now let's rewrite this number with just 3 significant digits. So we have to cut the number. So in order to round the number with 3 significant digits, we have to cut the number at the third significant digits. We have here 1, 2, 3. So we cut the number here, and we round the 4, because you remember how to round numbers probably, or well, in order to round numbers, the rule is really very simple, right? You decide where you want to round, and then the next digit you round. If it's 5 or more, you move the previous digit up. If it's 4 or less, you move it down. So in this case, we cut the number right here. So we have 3 significant digits here. So this 4, since the following number is 5, this 4 will become a 5. So this will be 3,250,000, like that. So this will be the number with 3 significant digits, 3 SigFigs. And take a look at that. I don't put the decimal point here. No decimal point. No decimal point here. No, so let's erase it. If I put the decimal point, when I put the decimal point here, these 4 zeros will become significant. So then I will have here 4, 5, 6, 7 significant digits. That's not what I want. So let's remove the decimal point. Now I have here this number, 3,250,000. That will be the original number given with just 3 significant digits. Let's do the next one. The next one has one captive zero here, so that zero is also significant. So all those digits are significant. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 significant digits. Okay, now let's rewrite it with just 3 significant digits. So we cut here at the 3, and then we have to round the 0 according to this number 1. This number 1 is 4 or less, so the 0 remains, so we don't have to make any changes. So the number will be 230. Here we have to put the decimal point. Why? Because if we don't put the decimal point, this 0 will become not significant. So in that case, this without the decimal point, like this is just 2 significant digits. This is 2 significant figures because it doesn't have the decimal point. If I want this to be 3 significant digits, then I have to put the decimal point. 230, so that's the original number. I'll remove these lines here. The original number with 3 significant digits. Let's do the next one. How many significant digits have this 10? This 10 doesn't have the decimal point, so this 0 is not significant. So this number has only 1 significant digit. 1. What about if I need to write this with 3 significant digits? Okay, then I have to write 1, 0, 0.0. I put the decimal point, so this 0 becomes significant, and all zeros, all trailing zeros after the decimal point are significant. So now this 10.0 will be 10 with 3 significant digits. All right, let's continue. Now the next one, 14.271614. All those are digits different from 0, so all of them are significant. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 significant digits. 8 significant digits. Now, if we want to rewrite this with 3 significant digits, we just cut here. So the following number after the cut is 7. So is 5 or more. So the 2 becomes to the next one. So this will become 4.3. That will be that number with 3 significant digits. Let's continue. 232,700. How many significant digits do we have here? These zeros for a number larger than 1 that does not include the decimal point are not significant. So here we have only one, two, three, four significant digits. 4. Now, what if we want to write this with 3 significant digits? So we cut here, we have 1, 2, 3, and the 7, the number next to the cut, is larger than 5, so the 2 becomes a 3, so this will become 2, 3, 3. So the rest we fill with zeros, right? Now, I don't put this decimal point, no decimal point, because if I put the decimal point, these 3 zeros will become significant, and I don't want them to be significant, so I remove the decimal point. So now this number, 233,000, with no decimal point, has only 3 significant digits. Next one, 0.0707070707. How many significant digits? All these zeros are captive zeros and also are zeros after the decimal point. For those 2 reasons, those zeros are significant. Therefore, all those zeros count. These zeros to the left never count as significant. Leading zeros to the left are never significant. So we start counting here. All these become significant. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 significant digits. Now let's write this with 3 significant digits without much explanation. I have to cut here. So 0.0707. That's that number with 3 significant digits. Next one, very interesting. Next one. This one, how many significant digits? Well, 1. There is nothing else to do there. The digits other than 0 are always significant, and we have only 1 digit, so that's 1 digit. Now, how can I write this with 3 significant digits? Well, I have to put the decimal point and 2 zeros, so the value of the 1 remains 1, but I add the decimal point with 2 zeros to the right of the decimal point, trailing zeros, in order to provide 2 more significant digits to that 1. Next one, this one. This 0 is to the left, so doesn't count as a significant. So the rest are significant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 significant digits. Now let's write it with 3 significant digits. We cut here. The next digit after the cut is a 6, so the 6 before the cut becomes a 7, so this will be 0.667. That's that number with 3 significant digits. The last one. How many significant digits? This 0 is captive, so it's significant, and these 2 zeros are to the right of the decimal point, or it is a trailing zeros after the decimal point, so they are significant too. So all those zeros are significant. Therefore, we have here 1, 2, 3, 4, 5, 6 significant digits. And now we want to write it with just 3. Then we cut on the third number, and then the following number is larger than 5, so the 0 becomes a 1, so this will become 3.41. That will be 3.40600 with 3 significant digits becomes 3.41. All right, so make sure you digest this. If you have any question, please contact me. We do more exercise. Or now let's see how this will affect the way you present your quizzes during this course. Let's say, for example, let's say I give you, in a quiz, I give you this problem and you have to calculate the reactions on this structure that you have there. Let's say you have to calculate the reaction at A, you have to calculate the vertical reaction at C, and you have to calculate the horizontal reaction at C. And you make a bunch of calculations. I'm not going to do the calculation here. It's not the actual, the idea to do the actual problem here. But let's say you do your calculations, and for reaction at A, you find that your calculation give you a number like 34 point whatever 703547311 or whatever. The calculator will give you many digits. Let's say that for CX, the calculator gives you 3.9745113. And for CY, you have, let's say, 300.27345573. You got those results in your calculator. In the Canvas platform that we are using for your quizzes, I cannot ask you more than one answer per problem. So I wouldn't be able to do this problem for you in a quiz because it has three answers. So the way I'm going to do this in your quizzes is that you are going to give me, if let's say I am asking for three answers, you are going to write those answers with three significant digits, and we are going to put all those digits in one number like this. Let's put the reaction A with three significant digits. So that will be 34.7, right? These three. To cut here, this 0 is less than 4, so the 7 remains. Now CX is 3.97, so you will cut here, so this will remain like 7. So this will be 3.97, and this 300.27 it will become 300 like this with three significant digits. Now you have the three numbers with three significant digits. I will tell you, give me your answer by removing the decimal point in those answers with three significant digits. Remove the decimal points and put all of them as a series of digits. So your total answer will be 347397300. No decimal points, no nothing. All right. So that's the way we are going to do the quizzes and evaluations in this class. If I ask you for two or more answers within the same problem, I will ask you to provide those answers with three significant digits, remove the decimal points, and put all of them in a string. And then the computer will see that string and will give you the credit. So if you don't cut the numbers to the three significant digits correctly, you eventually you did the problem correctly, but you put the right string of digits in the computer, and the computer will give you no credit. And look, if you make a mistake in one of those, all of them will be wrong. So make sure you understand how to cut a number to just three significant digits, so you are sure that you put your answers in the correct way in the computer. I'm going to give you like a trial quiz in order to check that you really understand how to provide answers with three significant digits, and also how to put together like three answers or two answers together by removing all the decimal places and put them together as a series of digits to make sure that you understand this very clearly, so you don't have problems with your quizzes. Make sure you do this trial quiz completely. If you get it wrong, do it again and again until you understand very well how to do this, because it's very important you don't screw it up at the point of writing the solution into the computer, because well, the important thing is that you solve the problem correctly, and then just putting the final result in the computer should not give you a problem. It should just a mechanics. All right, go fight or win. That will be for now. Take care.